Okay, class, we're going to finish up section 2.5, starting with problem number 8. It says use the trace feature on your graphing calculator to find the amount of caffeine left in your system after 90 minutes. Pay attention to units and don't forget that we're still answering incomplete sentences. Okay, first of all, if we look back on page 169, our time is in hours, not minutes. So we need to convert these 90 minutes to hours. So we would take our 90 minutes and use a conversion factor to change this to hours. It takes 60 minutes to equal 1 hour. Now when we multiply this, the minutes will simplify out and we will have 90 over 60. And if you put that in your calculator, that will leave you 1.5 hours. So now, instead of using the trace feature, which I think is quite clunky, let's go to the y equal feature and make sure that we have our equation in there, which is 180 times 0.80 to the x power. We will press second and window and go down to the independent because we know with our equation the x value is your time. So we will go over to ask and press enter, then press second and graph. And then you notice here that our table, our x value is empty. So we will type in how many hours we're using, which is 1.5, and press enter. So now our final answer here would be there is 128.8 milligrams of caffeine still in this person's system. And we are done. Now, we're going to move over to problem number 9. Problem number 9 states, use the graph to estimate the amount of time needed for the amount of caffeine to drop to 40 milligrams. Describe how you found your answer. Okay, so if we look here on page 169 again, we look here at the graph. At 40 milligrams of caffeine, that's between 6 and 7, a little closer to 7, so I say about 6.75 hours. So, what we can conclude is at 6.75 hours, or about, the amount of caffeine should drop to 40 milligrams. And again, we used the graph on page 169 to estimate our answer. Okay, now we're going to move on to problem number 10. Now we're asked for number 10 to use either table or trace commands on your calculator to try and come up with a more accurate estimate of the time needed for the caffeine level to reach 40 milligrams. Now, we could go back to what I told you before on the table. If you left the table the way how I told you, go into second window where you had the independent as ask. We could go back to the table. And remember, if we go back to page 169, if you look at between 6 and 7 hours, or even at the graph, we got it at 6.75, which would be about 40 milligrams. That's what we could start off trying. Let's try 6.75. And we notice here that it's at 39.914. So let's try 6.74. Now, if we're rounded to do decimal places, this would be as accurate as we could get it. So it says use either the table or trace commands. We're using the table on your calculator to try and come up with a more accurate estimate of the time needed for the caffeine level. So we could say it's about 6.74 hours to reach 40 milligrams of caffeine in this person's system. Now, we come down here to problem number 11. It says, make up a situation that could be modeled by each of the following exponential graph. As always, extra points for creativity. So we could use somewhat for the first one just off the top of our head from this exercise. We could use the cab fare example that we had earlier on. The cab fare, we could say that this cab, the first hour is $6, and each additional hour is $2. So we could say that this is 0 to 1 and then 1 to 2, and it'll show that we're steadily going up after an elapsed amount of time. Now on this one here, we could just basically start off by saying, we could talk about basically the stock market. You could just say you invested $10,000 and lost 5% each year. And that is an example of the exponential graphs. And we are done with section 2.5.